In this video, we'll explain why there are so many different styles and types of control valves. When the trim of the control valve changes its available flow area to throttle the flowing media, there can be some bad things that might occur. One of the things often talked about is something called choked flow. Choked flow just lets you know that some of the actual pressure drop going from P1 to P2, inlet pressure to downstream pressure, will not be used to push the flowing media through that control valve. As a result, the potential for bad things to happen can exist, if the wrong control valve style and trim type are selected. This is why so many styles of control valve bodies and trim types have been developed over the years. There are two main types of control valve designs, depending on the action of the closure member: sliding stem, also referred to as globe or angle, or rotary, also called quarter turn. Sliding stem control valves use linear motion to move a closure member into and out of a seating surface, whereas rotary control valves use rotational motion to turn a closure member into and out of a seating surface. If you think about a rotary butterfly valve or a ball valve, as you keep the inlet pressure and flow rate similar, the downstream pressure is going to be pretty much the same as the inlet pressure when it's wide open. That is, the downstream pressure recovers a lot of the initial inlet pressure. So that's called a high recovery device. Now if you take and switch to a sliding stem valve and have it wide open once again, you have a P1 at the same flow rate. Because of the fact that the fluid has to make turns and twists and go through the trim and finally out of the sliding stem valve, you're going to lose a little more of that pressure at the downstream outlet of that valve. Because it has a lower pressure, it's referred to as a lower recovery device. When you look at types of control valves, high recovery are your quarter turn rotary valves, low recovery are sliding stem valves. There are so many choices of control valves. Just because you have a minimum and a maximum flow rate, you shouldn't purchase a control valve only based on those factors. If you have a flow coefficient, you have a lot of different valve styles and trim types from rotary to sliding stem to choose. Within each of the valve styles, you have different trim options. Do you need aerodynamic noise abatement? Do you need anti-cavitation solutions? All of these things go into how we're going to select that control valve. What we need to keep in mind is once we do get a control valve flow coefficient, we need to use the manufacturer's suggested guidelines for selecting the proper trim for that control valve. You don't want to mix one manufacturer's selection criteria with a different manufacturer's, because chances are the principal operation of those two different control valves are going to be different. So make sure to keep with the manufacturer's selection guidelines for that specific valve vendor. Visit Fisher.com or contact your local Emerson sales office to learn more.